clicker? Perfect. All right. First, just want a little shout out for VeloDB. We're a real-time analytical database founded in 2022 by the creator of Apache Doris, which is the open source project behind the commercial company. And here's a bit of stat about the contributors, the members. We're headquartered in Singapore, and we just opened the US headquarters in Sunnyvale. So if you're around, please come by and say hi. We're in Plug and Play. And primarily our relationship with Doris is that we really try to make sure that we're contributing as much to the open source as possible, so that you're always going to get that interoperability, really kind of living to the spirit of open source. And we also provide a lot of support, so if you have any questions, even if you're using the open source, feel free to reach out, and we host a lot of events. Now, on to the topic for today. So we're going to talk about Real-Time Lakehouse, which is kind of an oxymoron, and I'll explain what we do to make this work. And a lot of the stuff we're going to go through may seem technical or complex, but they're really invisible to the user. It's really how we make sure things are easy. Oops. All right, so when we talk about real-time on Lakehouse, you've probably heard a lot of people saying, oh, just turn on streaming, or like just use Delta Live Table, or we'll figure it out and we'll run compactions on the fly, or whatever. But the reality is it's actually a lot more complicated and nuanced, and you may be running into more problems than you anticipate. You got the small file problems, that's physics. Your appending data, we'll talk about copy on read and merge on write in just a second. You got clustering, you got deordering, you got all sorts of optimizations, deduplications, you name it. And then when you get into ops and they start counting the number of techniques and tools you start using, and things start to get pretty hairy pretty quickly. Just to kind of summarize those problems in a little bit, we're really focusing on if you want to do real-time analytics, which means reading that fresh data as soon as it generates at a performance that's actually useful. Well, you need to handle data changes, because if your data is not changing, it's not real-time, right? So you got to be able to handle updates really well. And we're dealing with a lot of append-only systems, which is challenging because in a traditional database, you can just insert that row and you're kind of done, right? Not so much in a lakehouse. So we're gonna deal with that. Then you have query performances. Data management is such a fun field because you always have to make these weird trade-offs to try to get your work done. And in terms of query performance, it's the same, right? How are we going to, what are different points we can optimize? Are we reading files efficiently? Are we hitting I/O bottlenecks? We're dealing with S3, so I/O network, somewhat of a challenge. And then there's of course, the hidden cost of multiple engines, using multiple tools to get your data in, organize it, query it, and then also dealing with the complexity of serving that data in real time. So, sounds like a lot. And that's kind of where Lakehouse Analytics with VeloDB comes in. And we're going to talk about how we tackle each of those problems. But first, let's get a lay of the land. So what you see right here is the space that we play in. If you're interested in other things that we do, such as observability or customer-facing analytics, come talk to me afterwards. But for Lakehouse, this is the system that we're talking with. And for Lakehouse, it's all about interoperability, openness, right? So we need to be able to get data in. And that's where the integration with streaming comes in. So you see that we can take data from Kafka, Ursa, Pulsar. And we ought to make sure that no matter where your data lives, our solution works with you. So if you're using AWS Glue, that's kind of the stack we're going to talk about today. Or you're using Grafitinos, which is, we just heard about, or Unity and Polaris, we make it work with all of these. And it's important to do so because who knows where your data may be living. And on top of that, we want to make sure that we work with open storage. So making sure that it supports Parquet, ORC, and all the open table formats, especially Iceberg. Really exciting things coming out of V3, and some interesting talks of V4 that's going on. So definitely keeping on top of that. And then of course, the secret sauce that we provide. How can we make sure that we're writing that data quickly? Because we need to be able to get that data into the systems. And then how we're going to query that data with performance at scale, high concurrency, and low latency. And all the integrations into the other tools to consume all that data, such as BI tools and others. So if you want to learn about the full list of things that support, we can talk about that. But this is generally like any other data lakehouse architecture that you may have seen, making sure that we're participating in that ecosystem, and as well as working with partners to make special integrations to solve particular problems. So, getting into some of the challenges first, right? Data changes. And I talked about update being important, the ability to actually insert, update, and delete. And we finish all of these operations with a pen in a lakehouse. But that comes to problems, because when you're making that trade-off, you have to make the trade-off somewhere. Are you going to make the trade-off up front? Use copy on write. It will make sure that your query stays performant after the fact. But that's expensive, because now you're writing all of these files the moment it gets in, and as we just heard, it can be expensive because we don't know which files these changes will touch, and it could be a lot of files. Okay, fine. I need fast updates, so I'll figure that out later. Great. Copy on read, right? Just merge all the files on read. Yeah, but that's gonna cause some slowness when you read that file, right? Yeah, you can write that file pretty quickly, but when you read it, as the number of appends increase, your query speed is going to decrease, and now you're running compactions, clustering, and all sorts of other tricks, and that takes time, and it's complex. So here is a concept. What if you could get the best of both worlds? So we have something called merge on write. What does that really mean, right? What are you merging? What are you writing? Well, it's a slight play on word. But basically, what we're doing is, we know that append is the operation. We're going to continue to append. And as you append, then the only way you can solve this problem is, great, how do we make them merge faster? Well, if you're merging the data files, it's going to take a while. But if you merge a bitmap or indexes, that takes a lot less time. And that's what we actually do. So instead of actually merging the physical append files, all we're doing is merging the bitmap up top. So you can skip all of the files that are no longer relevant, and without physically rewriting the data. We'll rewrite the data eventually to get that eventual consistency, but during that real-time processing, you don't need to do that. Right? Now you can get to seconds level of latency, whereas before, it might be up to a couple minutes. So that's one. Then we're talking about query performance. So now we can get that data in very quickly. We can write with high concurrency, we can ingest quickly from streams, from CDCs, and so forth. And we have our own storage engine to do that. But when it comes to querying, you now have a couple of other challenges. I/O is another large challenge, especially working within a lakehouse. Reading ahead, making sure that you're optimizing reading the actual files. And then there's the scanning of everything. Because you're reading into a lakehouse, you often have to be very, very particular about how you scan those tables. You get some pretty big tables, right? So let's talk about the first one. So we have a way to read ahead, to anticipate, and then we're merging the I/O so that we're not going back and forth getting to that data, improving that efficiency. Then we also do multi-level caching with partial results refresh, so that you need to go to the source even less. If the data is not changing, you don't even want to go and fetch it again, right? And together, we're able to cut latency by significantly. File reading optimizations. You need to be able to read files quickly. And there we invested a lot in native Parquet readers. Really just being able to read that file quickly. And then we're taking a page out of traditional computing with data federations and predicate pushdowns, so that we can push down the filterings into the storage layer. You might wonder, well, how do you do that in S3? Iceberg lets you do that. Finally, with lazy materializations. So we really defer loading that data. Again, it's really minimizing the amount of data that we're actually moving until we really needed it. And this allows us to reduce the memory usage and also the I/O bandwidth. So you can see that even as we're optimizing some of these file reads, we keep in mind the I/O limitations, as well as just physics about reading files and so forth. And then finally, when it comes to query performance, there's always the query planning and scanning of files, tables themselves. So as we're planning the query executions, we take into account of how do we actually want to do the scanning, so that we prioritize it based not only on the table structures, but also where that data is actually sitting, and the complexity of actually performing those operations. And in addition to that, we also do partition pruning at runtime. So we're really eliminating as much of that partition scan as possible. In summary, less data over the network, more intelligent in scanning our tables, and then being able to read whatever data that's left fast. And all of this is able to get us to second level performances on S3. Now, all of this is just what I talked about are just the tricks on lakehouses. But Apache Doris and VeloDB was built for real time. So from the beginning, there are these additional features that are already in place to offer you real-time performances. So we're built on top of a full vectorized engine, so it's both C++. We have a cost-based optimizers, and we have pipeline executions, as well as additional indexes and caching, so bloom filterings, min-max sums, and there's actually a couple of new ones, such as top-in, that are coming, that I'm going to talk about in a bit. We also already have smart caching with a ton from before with the multi-layer caching, so you can get data on S3, data on NVMEs, data in materialized on MDB and memories. And of course, there's the materialized views and the partial updates that we support there, as well as the architecture itself, which is massively parallel scalable, and we have both a row storage and a column storage. So these days, not a lot of people really uses the row storage unless you really want that extreme performances. So built on top of more techniques. There's really no one silver bullet. It's really additive, adding up all of these little bit of performance gains to get that end result. Now, I talked about the two sides, and multi-engine complexity and a lot of complexity are handled by the inherent architectures because we can both write the data and read the data. You actually may need fewer tools to get the data in as well as reading it. And today we're going to talk about what does the stack look like on the Amazon platform. One of the things that is kind of a stealth launch, and I guess it could be seen as a me too in the market, is Amazon S3 tables. So essentially, Amazon, on top of their S3 buckets, has also created a managed table. So it's Iceberg compatible, and it handles a lot of the nitty-gritty and annoying things about real-time workloads, such as data updates. So for example, it supports schema evolutions, partition evolutions. It handles a lot of the compaction and optimization, so you don't have to really worry about it. And of course, it has Iceberg REST catalog and the governance hook into a range of governance solutions that it supports, as well as commonly used ones such as Ranger and so forth. And if your data is already on S3 and you're building on the S3 stack, it's a really convenient way of not having to deal with Iceberg tables. Though many folks already are doing it, and we can work in both ways. So what does that really look like when we actually put this together in terms of a stack, right? So the first thing is we talk about what are all the data that could coming in. So in this case, I really just kind of provide a simple example of a Confluent connector sending data into Amazon. And this data can land directly as S3 tables or as Iceberg tables catalog with Glue. Either one works. And if you're using vanilla Iceberg tables, actually used TableFlow before, it'll work fine. But if you're not, you can actually just use a Kafka connector, and then you can dump it into S3 tables. But today I'm going to show how VeloDB interacts with the S3 tables. So in a second, I'm going to play a quick video of showing how you can use VeloDB to directly interact with S3 tables once you connect to Glue, once you connect to the S3 warehouse. So here is the environment of the SQL screen for VeloDB Cloud. And we provide you a SQL editor, a search analysis where you can actually perform search on the same data. In this case, we're going to look at how we can connect to a table. All right. So first, I'm going to go to the catalog. And you notice that even if you're a novice, it can be very easy for you to start integrating tables and data. So from here, I'm going to add external catalog. And you notice that there's a list of tables that are available from the UI and catalogs. And I'm going to click on S3 tables, which is right there. And from here, it's pretty much standard sets of information to get connected. I'm going to name this my S3 table. And then I'm going to provide the Iceberg REST URL as well as the warehouse bucket name. And then I just need to name the regions. US East 1, still using it. And then from there, just the access key and the secret key. Very straightforward. And then, that's it. You're connected. From here, you can start to create tables, insert data, query the tables, and use just regular SQL commands. And you can actually kind of look at some of the database creations, and we're gonna move forward. Sorry guys, it looks like I have a slight wrong video uploaded, so my apologies. Let me actually find the right one. Oops. Okay, my apologies. It looks like I uploaded the wrong video. But from there, you basically can create tables using just create table commands. And then you can insert data and then query table from just the SQL editor. So apologies for that. And I promise I will have a video uploaded with the deck when we share this out to the crowd. Sorry about that. But so moving on. So I want to talk a little bit about Apache Doris, the technology behind VeloDB. And just to show you kind of like the scale of the community that we're working with. And this is with 700 plus contributors. We're really big in APAC. In fact, the project started out of Baidu as a project for customer-facing analytics in real time, so really ad targeting, behavior targeting, and the technology has really evolved to handle a mixture of workloads. For example, for the past 3 years, the team at VeloDB and Apache Doris has invested a lot in search capabilities, in addition to real-time capabilities. And we're continues to really meet customers where their issues arise. And I'm really excited to talk about Apache Doris 4.0 because one of the things that our customers really appreciate about VeloDB and Apache Doris is the fact that we can handle a variety of different workloads with a single engine. Now, what does that really mean? So we talked about the ability to actually query tables, as well as search the same tables, as long as we add a inverted index to add that performance. But more and more so, we're starting to see additional workloads involving AIs, building context engineering, or AI agents interacting with databases. And on that front, with Apache Doris 4.0, we actually are releasing a whole slew of AI capabilities designed to really make sure that customers and users can continue to do the work related to their organizations on the same engine. So instead of having to move data between different engines, between different environments, we're really trying to help them consolidate and to make building new things easier. So first thing that we're releasing with Apache Doris 4.0 is vector indexing. So this is the hierarchical small world index, where we're able to provide much higher QPS compared to before without the additional vector indexing. We also release a whole slew of AI SQL functions. So instead of having to add a glue layer between interacting with your database and your model, such as using Python, you can actually use SQL directly to interact with LLMs. And we also introduced a new full text search, a brand new search function, basically bringing a lot of these search capabilities directly into the SQL interface. Again, you're already able to do so from full text search and SQL directly. This is now just making it even easier. And what's really cool around the batch workload and the ELT space is that we're actually adding a new disk spill feature. So for those who are familiar with Spark and a lot of the batch processing engines, disk spilling saves significantly on memories and can reduce the overall footprint that you're operating in. And then finally, we also added the additional set of performance gains, top-end, lazy materialize, and cache improvements on the core engine side. So make sure that we're continuously improving our engines for all of the workloads that we currently support. So if you'd like to try this out yourself, we offer a 14-day free trial that you can get in without a credit card. So if you like what you see, feel free to go check it out and use the QR code, start an account today. It should only take you one click. And finally, if you'd like to learn more about VeloDB and Apache Doris, check out these resources. We are very active on Slack, and you can download Apache Doris and play with it yourself. Or again, if you just want to get started quickly, check out the SaaS offerings. It is identical to the solution that is on open source. All right, thanks everyone, and have a great evening.